I think we're going to kick off now then. So first of all, I just wanted to welcome everyone to this lunchtime webinar, which is hosted by the Engineers Ireland Water and Environment Society. My name's Sheila, I'm the chair of the society, and I'm just chairing the session today. So I'd like to welcome everyone to this session. It's the second in a series being delivered by Saint-Gobain. Last week we were talking about ductile iron pipes. This week the topic has moved more towards standards, and the next session, which was due to be at the end of March, is now going to be in April. So just please watch the Engineers Ireland website for details of the third session, which will be confirmed in the coming days. And so without any further ado, I'm going to hand you now to Phil Green, who's the technical director in Saint-Gobain. Martin Addison is also on the call today and will be assisting with the Q&A session at the end of the talk. We're hoping to run for about 45 minutes with a session on Q&A towards the end, and please submit your questions using the Q&A box at the bottom of your screen. With that, over to you, Phil. Thanks.
Right, so this afternoon's session is about European quality marks and standards. Can be a bit of a dry topic, but it's really important that we understand how quality marks fit together and what they build and how they build up the correct specification for a project. So we're trying to understand what the standards are, how we disseminate information, and the various marks, quality marks that are associated with ductile iron pipe products. In a moment, it's not moving on. There we go. Right, that's moved. The screen's moved. Take it, Martin. Just confirm.
Yes, that's right, Phil.
Thank you. Right. So the object of this is to improve understanding of the marks, as I mentioned earlier. Understand the roles that they play in specification. So we're talking about various things today. We're going to talk about European standards, trying to understand what they are. How was it created? Who are responsible for European standards? How are national standardization bodies involved in this? How an EN becomes a BSN or an IREN in Ireland, and what are relevant to ductile iron? And then talk a bit about quality marks and what they mean, how they work and what they mean. So basically, a European standard is a complete and precise definition of a product, a system, a process and a service. They're created by consensus and distributed by an independent body, which is SEN, which is the European body, standards body, and is nationally and internationally empowered to do so. Basically, standards are reference documents that provide technical information and a commercial means of understanding that technical information, and they're an essential tool in public procurement and specification definition for commercial contracts. Standards are generally voluntary in application unless they're called upon or cited in a contract. So how are standards made? So basically, you've got SEN who sit in the middle as a business facilitator, and they act as the sort of central hub of how standards are built and put together. At the side of this, you've got 31 national standards bodies in Europe that form SEN. Now, these are, SEN is part of as I say, a central body, and there's a directive, European Directive 9834 EC for the planning, drafting, and adoption of European standards, and all these are managed through the SEN body. So when you're creating standards, there are various national bodies that associate into SEN. So you've got all these sort of national bodies. I'm talking about the UK at the moment, so BSI, AFNOR in France, DIN in Germany, NEN in the Netherlands, etc. So there are various national standards bodies that fit into SEN and feed into SEN to develop and understand standards going forward. So technical committees for different products are classed as different technical committee references. There's a technical committee that covers ductile iron pipes and fittings in Europe, and that's TC 203, of which I'm a member. And then all of these national bodies have an opportunity to be part of TC 203 or can make comments about standards that are being derived by this particular committee. So in pipes and fittings, there's a technical committee TC203. In plastic pipe, there'll be a different technical committee. In surface boxes and manhole covers, there'll be different technical committees, but they all work in the same way. They act as a hub around the SEN Central Committee, and they are made up and managed by members of national standards bodies, and they all feed into that process. So in terms of SEN membership, as you can see there are a number of members of the SEN committee, and all these people feed in to the development of standards. Obviously, BSI in the UK, in Ireland it's NSIA that act as part of this particular standards development body. Now, you might think with Brexit, why are BSI still there? Well, Senelec voted overwhelmingly in 2021 to maintain the link with BSI, to ensure BSI were still represented in standards bodies, because the UK plays a significant part in developing standards. So the Senelec board decided to maintain the reference to BSI. So all of these stakeholders have an opportunity to contribute to standards, and they play a part in developing standards going forward. And that's just a quick snapshot of the body of countries that are involved in standards. Now, what you've got in a standards committee, each member body can nominate a representative to a technical committee. These representatives might be the leader of a national delegation, or a principal expert, or some kind of specialist in a field. For ductile iron pipes in the UK, BSI nominates appropriate representation to TC203, and that representation then acts on behalf of the UK in terms of BSI. So I'm a member of SEN TC203, acting on that technical body, but I represent BSI. My capacity in that membership isn't to represent Saint-Gobain PAM, it's to represent the interests of BSI in that particular body. Although I'm if you like, a nominated expert from a manufacturer, we have to consider the views of a range of different stakeholders in that process. Now, TC203 for ductile iron pipes, it covers a number of different things. It covers water pipelines under pressure, sewerage pipelines, soil pipelines, couplings adapters, influences of non-metallic materials, revisions of EN 545598, and it's starting to look at sustainability. Life cycle cost and life cycle analysis are starting to come to the fore in terms of what standards are looking at and how they're being developed. As I mentioned, that all fits together, as we said previously, membership and representation from all those countries into those technical committees. So I'll talk about Britain, for example, but other countries will have a very similar spectrum on this. BSI is a mirror group that matches into TC203, and the mirror group, which is called PSE 10, meets to vote on acceptance and rejection of draft standards, and provides responses to the European standardization, which falls within the domain of TC203. So, as I mentioned, in the UK, we've got PSE 10. I happen to be chair of that particular standards committee, so within the UK, we've got representation on PSE 10. I chair that committee, and there are representations from other ductile iron pipe manufacturers, couplings and adapters, stakeholders from consultants, and from UK water PLCs. So there's quite a broad spectrum of people who are involved in that particular group that feed into standards. So it isn't, as I mentioned earlier, it's not a Saint-Gobain say so it happens this way. We're just part of a conduit of information that supports this. And then what happens with PSE 10? That mirrors TC203, so that we have a good understanding of what's happening at the European level, so we can apply that locally to national level. And similar things will apply in your particular area. There'll be a representation or a reference back into TC203 locally in Ireland. So in terms of European standards procedures, the process by which a standard is created begins with a proposal from a technical committee. The proposal is then put to the membership vote, and once approved, the work item is passed to the relevant technical committees for action. And the technical committees working on a proposal will pass the work item to an existing group or a working group that will manage that particular process. So, for example, TC164, which is the technical committee responsible for water supply. There's a working group 3, which deals with the effects of materials in contact with drinking water, and then there's an ad hoc group 6, which deals specifically with the influence of cement-based materials on water intended for human consumption, and so on and so on. So you can see you've got a bit of an alphabet soup there of numbers and references. So TC164, WG3, AHG6. It does have meaning to it. So there's a method to the madness in the way these things are defined. We mentioned on here about the approval of requires 71% of memberships to vote in a weighted vote. It's interesting from a weighted voting perspective. So across the interested parties in Europe, this is the weighting on votes for particular standards. So you've got, if you like, the traditional leaders of European standards, France, Germany, Italy, and the UK have the highest weighted vote ratio there of 29. And if you look, Ireland on the right-hand side, fourth one down, Ireland has a weighted vote of 7. So you still have an influence, or perhaps not as big a weighted vote, or not as big an influence as the people that generally drive the standards, such as as you say, the big 4 on the left-hand side there. But that puts a bit of context to the process of voting and why we get to certain decisions in a voting process. Even after, as I say, even after Brexit, the UK retains its previous and significant portion of the weighted vote, because there's a recognition that UK representatives are members of lots of European standards committees, so we still have a big role to play and a large influence that we can bring to development of standards. So in terms of procedures, a bit more about procedures. Basically, what happens when a standard is being developed? A work group produces a draft standard. It passes it to via the technical committee to the SEN for translation and harmonizing. And generally, standards are written in 3 languages: English, French, and German. And SEN then disseminates this information to national bodies, and then national bodies can make comments or pass back SEN these comments to either change or make recommendations of change to a particular draft of a standard. And then the final draft of a standard is prepared by the work group and again passed to the SEN Central Committee for harmonizing, disseminating to member bodies as a what we call a PREN. So that's basically a pre-European standard, which means that it's gone out to comments have come back, the standard's been revised, and it's gone out as a pre-standard for final approval. So there is an iterative process there that if people strongly disagree with a particular reference in a standard, they have the opportunity to comment on it and make a recommendation for a change, and then that goes back into committee to be looked at and worked through. And generally working on consensus, that's how we manage to develop standards based on consensus of stakeholders. So member bodies are then given a set period, which is usually 3 to 4 months, to comment and vote on the PREN. It's a yes, no, abstain vote, and then technical comments are usually discussed at the working group level, and if accepted by a majority vote, it then becomes an EN. So there is as I said earlier, there's a process and there's rigor to that process, so that standards are managed correctly and the right level of information is included within standards. And that's just what I've got here is just an illustration of a record of voting. So when you do a vote on a standard, there's a document back in Central European Standards Committee references that tell you who voted, what their vote was, and whether they provided any comments. Just in terms of comments forms, just before we move on from this, as I mentioned earlier, have stakeholders that have an opportunity to comment on a standard or a PREN or a draft standard, and there's a format in which you do that, as you'd expect from a European Standards Committee. You have to follow a particular process to provide information and comments back. And this is a typical example of what a comments form looks like. You have to reference which member you are, which subclause you're commenting on, what the type of comment is, and then what your comment and proposed change might be as part of that submission back. And that's a bit more of a detailed version of one of those forms. So in this particular instance here, people have made comments. They've talked about what type of comment it is, editorial, technical. They've commented on what the change might be, and they've proposed what that change ought to be in the body of the standard. So as I mentioned, there's a process by which things get measured, challenged, and recorded. So the send timetable for issuing standards once they're finished. There's 3 months for send to finalise the standard. There's 6 months for the body to formally ratify the standard. Then it becomes a BSEN or a NFEN or a DIN-EN or whatever country it might be. And then you have 6 months to withdraw old standards. And local standards, local bodies, for example, BSI, could put amendments in there or addendums in that suit their particular country, but it's known as an Annex NA. So you could put a local requirement in, but that requirement applies only to that particular country that's put that annex in. So that's what happens with the European standard. And then if there's no European standard for a particular application, so again, back to the UK, BS standards still exist where there's no European standard to be adopted. So an example there of British standard 4027, there's no European standard for that. That's for sulfate resisting Portland cement. Out of interest, there's no European standard to replace that. So in the UK, that is the standard that still drives that particular product component definition in the UK. We talk about harmonized standards. Where the product's covered, where the product covered in a standard is within the scope of the Construction Products Directive, which is again a European directive, and where all standard is the same in all countries, i.e. there's no local annex, then the standard is harmonised and will contain an Annex ZA, which has got the requirements of the CE marking in it. CE marking then becomes obligatory after a transition period for all products that fall within that particular standard. There's again a challenge for not for Ireland, but a challenge for the UK in this particular instance, in that we now have what we call a UK CA, or in the north of Ireland a UK NI mark instead of a CE mark. But they're both CE equivalents, but because the UK decided to leave Europe through Brexit, we've now got different marks for UK and the north of Ireland, but they are equivalent to CE marks, but we've got a different certification body now because we're not part of that European certification body. So basically, they mean the same thing. They've undergone mandatory third-party conformity assessment against the relevant regulations by a body based in the UK. So that's how CE marks or UKCA, UKNI marks come about now. Some standards that are relevant to the water and sewage industry, and I'm sure a lot of you people are aware of these and use these regularly. BSEN 545, ductile iron pipes and fittings. Now, that is a product standard. Now, in terms of the effect of water quality on human consumption, this particular standard doesn't define this, and it doesn't define this in any of the countries using it. So basically what we've got there is a standard that governs product, but because it's not a harmonized standard, every country is responsible for its own water quality elements of EN 545. So what there is in Europe, there's a desire across SEN to try and harmonise water quality regulations, and if you like, the big four of France, Germany, UK, and the Netherlands are investigating the possibility of a common approval scheme for water quality. I think this is some years away though, because the group that was the 4NS group now includes other countries. So I think there's now 6 or 7 countries in that group that are trying to develop a standard water quality process. So it's in danger of becoming too large for consensus. So, for example, in the UK, we have the Drinking Water Inspectorate, who govern what drinking water quality standards are, and I guess in Ireland you also have Ireland governmental guidelines on what drinking water quality standards are, which you have to adhere to. So although the product meets a European standard, the application of that product and the review of its its effect on wholesome water has to be viewed by a local body to make sure it meets those particular requirements. We've also got EN 598, which is ductile iron pipes and fittings for drainage applications, sewer and drainage applications. This is a harmonised standard, so products covered by this standard will require a CE mark, and we'll come to that in a bit more detail later on. We've got BSEN 12842 for ductile iron fittings for PVCU or PE piping systems. So again, some of you guys might be familiar with this. If you're putting small diameter plastic pipes in the ground, you might still need fittings for those pipes, which are ductile, and this particular standard covers those particular fittings. You've then got EN 14525, which is ductile iron wire tolerance couplings and flange adapters for the use with different types of materials. So again, that standard covers couplings and adapters which are used with ductile iron, with PVC, with polyethylene, with steel. So there's a governance on that. Although the product itself is a ductile iron product, it might cover a range of different material types. So in that particular standard, we have to make sure we've covered the performance characteristics of a range of different materials within that standard. And then we've got EN 14628, which is external polyethylene coatings for pipes. So there's a number of standards there that apply to products that Saint-Gobain provide, and that you might use in your particular applications on a day-to-day basis. More standards relevant to water and sewer. We've got BSEN 14901, which is epoxy coating of fittings, of ductile iron pipes and fittings. And again, this is really important because this is a standard that's used with ductile iron with 545 to reference the coating requirements on fittings. So fittings, ductile iron fittings that are supplied to European standards should be coated in accordance with EN 14901. 15189 is external polyurethane coating for pipes, which is again PAM TT Pux coating. And then there's a standard 15542 for external cement mortar lining for pipes. And then EN 877 for cast iron evacuation of water from buildings. And then we've got EN 969, which are pipes, fittings, accessories and their joints for gas pipelines. Now you'll note on this particular standard, it's quite an old standard, 1996. Saint-Gobain and ductile iron manufacturers now don't provide products for gas applications. However, there are networks in place that previously were ductile iron that use ductile iron pipes and fittings for gas. So this standard remains relevant and current because if there's any rehab work needs to be done, people are excavating and it's a gas pipe, it's made in ductile iron, they can refer back to this particular standard to understand what the governance was for this particular product group at that time. So it's still relevant to keep that out there so that if you are excavating or replacing old gas mains, you know what the standards were that drove them before if they were made in ductile iron. Other standards relevant to the water and sewer industry, EN 196 for cements, 197-1, which is composition specification for cement and cement mortars, 681-1, which is elastomeric seals, gaskets and seals. So again, in terms of a pipe system, you need a pipe, you need a joint, you need a gasket. So 681-1 governs the performance characteristics of gaskets. You've then got EN 805, which is the requirements for systems and components outside buildings for water supply. So in that, it talks about installation and test criteria that you need to apply. EN 1092-2, flanges and their joints. So again, when we speak to merchants, contractors, consultants in Ireland or in the UK, we often ask what PN rating they're working to. It's generally PN 16, and what we mean by that is the pressure rating of the flanges, and all this is governed by 1092-2. So that's what there is, again, some alignment with the PN rating back to a standard so that everything's consistent and meets some level of assurance. We've then got 10002, which is metallic materials and testing. ISO 4016 for bolts, 4034 for nuts. So again, everything that you might use in a pipe system, joints, nuts, bolts, washers, they're all covered by particular standards. 14339 for underground fire hydrants, and EN 1074 for valves for water supply. And in 1074 for valves, there's a number of different subcategories in that cover hydrants, gate valves, non-return valves, butterfly valves, etc., etc. So within that standard, there's sub derivatives, should I say, not substandards, sub derivatives, which guide different product groups for valves. So that gives a flavour of the type of standards that we could expect or look out for when you're designing, developing and installing a system in ductile iron or indeed any other material. So quickly working through a European standard, what's defined. We'll just go through it in a little bit more detail. What does a standard look like? How is it made up? So pretty consistent format in terms of the way standards are built. You've got the introduction, the scope, the normative references, terms and definitions, technical requirements, etc., etc., and then any annexes that might sit at the back of these. So every European standard you see, every EN you see, should follow a similar format and have that level of familiarity with it in terms of what's contained within it and where to go and look for things in a particular standard. In a bit more detail, the foreword defines who's responsible for producing the standard, what if any other standards it replaces, which annexes are normative and informative, which countries are bound by the standard, and any relevant EU directives. So that's sort of a flavour of what the standard is all about, what it meets, what it replaces, and if we're being governed by any other directives as part of this development of a standard. And then into a bit more detail, you get to the scope, what's covered by it, and perhaps more importantly, sometimes what's not covered by the standard. Then the references, normative references, define any provision from other standards and publications which are cited within the text. Where you've got dated references, for example, EN 545/2010, subsequent amendments or revisions only apply when they've been incorporated into the standard by amendment or revision. So if 545 was referenced in the standard as 2010 and we revised that in 2020, unless you revise that reference, you have to work back and use the 2010 reference as your reference for this particular element in the standard. Where it's an undated reference, as we've got there, EN 598, for example, it's always the latest edition of that standard that's been referred to. So that's probably more, what's the word I'm looking for? It's easier for developing and writing standards if you use the latest version, i.e. don't put a date on it, because automatically you'll look at the latest version of a standard for the information. But there might be specific information on a dated standard, which is critical, therefore you have to reference that particular dated standard. Terms and definitions. All terms which have or may have a specific meaning with respect to the standard. A couple of examples there about minimum and maximum insertion depths, for example. Any abbreviations. So if there's an abbreviation in the standard, we have to tell you what that means. So allowable operating, so in EN 545, for example, we reference PFA. That means allowable operating pressure, which is internal pressure exclusive of surge that a component can safely withstand in permanent service. And then that cross references to EN 805 for testing. So you start to see where standards reference something, give a term, and then it references another standard for how that term is applied in the real world. Then we talk about any values resulting from equations. We've got an example there of what that means. So again, we try to be clear in the terms and definitions so that for the layman reading a standard, you can, if you don't know what it means, you can go back and look at a reference piece to say, get what you're trying to tell me now. I don't necessarily understand it, but at least I understand what you're trying to tell me. In terms of technical requirements, this section in the standard gives general requirements such as colour, condition, and joints. Major dimensions, again, relating this to ductile iron, it would be length, diameter, thickness. Material requirements would be the tensile strength and the hardness of the materials and the elongation capacity. Coatings and linings, what you're putting on the inside and the outside. Markings, what markings you have to put on pipes to make sure they're easily identified and meet the requirements. And then leak tightness of joints, how you go about testing for that and defining what the process is to make sure that's been followed through and validated by manufacturer and third party. So there's quite a lot of technical requirements in there. And then you've got the performance requirements. So this defines basically that the test requirements confirm the fitness of purpose of the product within its scope of operation. So it talks about what tests you have to do to make sure that the product you're developing meets the particular characteristics that you've defined in the standard. And these tests can be routine tests according to a defined schedule. There can be a once only test on a sample of a product, which is considered then to be a representative sample of the range. And in this case, they're only repeated after a change of design. So an example of that is where we have type tests. So Saint-Gobain PAM have a range of different joints and different sizes of pipe. So what we will do, design a pipe, we do a type test, which is a one-off performance test, which ensures that that product meets the performance standards that are required in the standard. And then if we change anything on that product subsequently, we have to retype test it to ensure that it meets that requirement. We don't have to test every manufacturing batch, but as long as we're manufacturing the same product with the same parameters, we have that type test that demonstrates its proof of performance. And then as part of that proof of performance, this forms the basis of quality marking, i.e. kite marking or CE marking or third-party accreditation or whatever that might be. In terms of test methods, again, this defines the way in which the product must be tested to demonstrate compliance with the technical and performance requirements defined in the standards. Any reference standards that are used to carry out the tests, the error limit or the accuracy required for testing, and then how you might calculate the result, because different materials are performing in different ways. So there are certain circumstances, for example, with plastic pipe, not necessarily ductile iron, where because of the change in mechanical properties over time, you extrapolate results, or you do accelerated testing and extrapolate results, because you then calculate what that long-term life might be based upon an accelerated test regime. So there are, if that's involved in a standard, you have to demonstrate and define what that calculation process is and what it actually means and how you interpret it. You've then got tables of dimensions for products. So again, looking at ductile iron pipe, for example, you've got multiple size or shape products. You've got the functional dimensions with the maximum minimum tolerances. Then you've got the range of standardized sizes for different components. So you have to give the consumer or the user an idea of what the range is, what the max and min sizes are, and what the scope of that range is for a particular product. Then you get on the evaluation of conformity, and as I mentioned earlier about testing and type testing. This evaluation of conformity defines the requirements for initial type testing, how you do that testing, how you sample products to enable you to do that testing, and how you keep records for that testing. And then you've got factory production controls. So again, if you do a type test and the product meets that requirement of a type test, that's great. And you keep that information as a reference point. You also have to make sure that you're managing your production controls in the factory, which will be an ISO 9001 process, so that you're doing things the same way and repeating the process. Because it's no good having a type test on something if you then change the process in the plant. It's not representative of the type test that you did. So there's a requirement to look at how you manage your manufacturing process, your sampling process, your frequency of testing, your record keeping, your batch quantities, etc., etc. Within testing, and again from an EN 545 perspective for ductile iron pipe, there's a requirement in there as an evaluation of conformity for 100% hydrostatic testing on all pipes and fittings which are manufactured, not batch testing. And that's quite an interesting one, because we're often asked by customers, do you test every pipe? Yes, we do, because that's what it says in EN 545. So we hydrostatically test every pipe and fitting that is manufactured by PAM, because that's what the standard tells you to do. What the standard also asks you to do is measure the wall thickness and control the wall thickness by ultrasonic measurement for consistency and control. And again, that's what Saint-Gobain do. That's what the standard asks for. That's what Saint-Gobain do. So for all those pieces that are asked for there, we can give evidence and supporting documentation, certification to demonstrate not only do we meet the type test, but we meet that factory production control process as well through ISO 9001 and or regular audits of the plant by third parties. What's really important, that is, because it's all right saying that a product meets a particular standard. The detail in the standard is what it should meet, not just, oh yeah, it's a ductile iron pipe and it's this thick. Part of that requirement of conformance is to make sure you've got these records of control in place as well for consistency and control of your batch and your one-off manufacturing. What we've got then is annexes in a standard, and these are the parts of the standards that are attached at the end of the main body. You've got a normative annex, and this normative annex has the same force as the rest of a standard. It might be an annex because it's an optional feature which, if provided, must comply with the specific requirements, or it may be an annex to avoid complication of the body of the standard. So you know, it's kept out the way and put at the back, but you still need it, and we've put it at the back so we don't confuse the base products within the standard. An informative annex, as the name suggests, basically gives information rather than instruction. So these are, if you like, nice to haves as information, not necessarily thou shalt, but it's good information about the product or the application. You've then got an annex ZA, which is basically in a harmonized standard. This is the checklist that's provided in a harmonized standard, from which the manufacturer can list out all the possible requirements of the product and how these can be met within that particular Annex ZA. The European directive, which is the Construction Products Directive, fixes these essential requirements. So for EN598 pipe, if you look at EN598 standard, there's an Annex ZA, there's a set of requirements from the European Construction Products Directive, which fixes these requirements. So any manufacturer that provides a 598 pipe has to have a certificate of conformity to the European Directive Annex ZA. That's over and above any other certification that they might need. In fact, it's a declaration of performance, actually, not a certificate of conformity. With an Annex ZA, it's a declaration of performance because it's a self-declaration. The supplier of that product declares that it meets this particular, or gives you the criteria that it meets as part of that Annex ZA. I guess that leads us into quality marks as well, because there's lots of, we talk about standards, but how do we apply them? How do we measure them? What are the quality marks that go with the correct use of standards? So in terms of quality marks, there's various certification schemes which might be used to qualify a product. You've got CE marking, which we've just touched on there with the Construction Products Directive. We've got national quality marks, and these are of significance because there are no European equivalents to national quality marks. These are a guarantee of conformance of the products and the service against all of the requirements of the standard. You've then got management systems, ISO 9001, environmental systems, ISO 14001. So there are a range of quality marks that can be applied to a standard. And then you've got so again, from a national quality mark in the UK, you've got kite marking, for example. So a product that meets the requirements of EN545, it doesn't necessarily need a kite mark. If we choose to then locally within the UK do further testing to get that certification, we can then have a kite mark as well, but we can also have a certificate of compliance to the European standard. So that national quality mark is specific to the local country. Where that product might be used. So if we look at CE marks, and as I mentioned earlier, CE marks have been muddied. The waters have been muddied by the Brits again. So in the UK, it's UKCA, and in the north of Ireland, it's UKNI as an equivalent to a CE mark. So basically, what the European directive does, the Construction Products Directive, it basically fixes the essential requirements to allow free movement of products throughout the EU. Generally, these are defined in Annex ZA of a standard. And Annex ZA also defines the level of attestation required to demonstrate performance, and that can be anything from a self-certification right through to a third-party test. So again, it's also important when you have a product that's got a CE marking, the declaration of performance, it's useful to understand, well, what level of performance does that mean? Is it a self-certification, or has it got more depth? And we'll go into that in a bit more detail now, what that actually means. So in terms of levels of attestation, they're shown in this table. The associated requirements are shown in the table. So the example includes cement for construction industry, which is a level 1+, masonry for construction industry, which is a level 2, and tile adhesives, which are usually level 3. It's interesting to reflect that the level attestation for underground fire hydrants is level 1, meaning that third-party witnessing or testing is required for these particular products. And then you have to audit that and ensure that you continue to manage and cover that with sort of surveillance by third parties to make sure that it meets that criteria. Whereas the requirement for ductile iron pipes is actually a level 4, where only a manufacturer can declare, well, a manufacturer alone can declare a level of performance. So a manufacturer can say, oh yeah, we've looked at this particular product, it meets the requirements, it's a level 4 approval and attestation. So you could say the level of attestation reflects the safety criticality of the product. So you can assume that the failure of a ductile iron pipe of a sewer is less critical, perhaps sometimes, than the loss of a tile around a sink. But it just gives you a view of the levels of attestation that are required. And in this particular instance here, a fire hydrant would be level 1 plus, because it's a critical critical component in a network. If things go wrong with that, it can injure people, things can go wrong. A ductile iron pipe, I guess, if that breaks, you get a leak, a leak problem. But it just illustrates the point. If somebody gives you a CE marking for a ductile iron pipe, it doesn't necessarily mean that it meets the requirements of the standard. It just meets the declaration of performance that's listed in the Annex ZA of a standard. So going into a bit more detail on CE marking, as I've just mentioned, CE marking only confirms conformance with the defined essential requirements. So the Annex ZA of a standard. If it's a construction product directive, it's the essential requirements as defined in the Annex ZA. It doesn't necessarily mean it confirms compliance with the whole of the standard, and it does not necessarily mean it confirms that this third-party attestation for that particular product. I mean, basically, level 4 only requires a manufacturer to give a declaration that meets that requirement, and that's enough to give you the CE marking. So basically, a CE mark can sometimes demonstrate a manufacturer's declaration, but it isn't proof of compliance to European origin, and it's not a quality mark. So it's really, again, important to recognise that when you're assessing different products. CE markings are good, but they're even better if you have other marks alongside them. If you have a CE marking on its own without a quality mark, particularly on ductile iron sewer pipe, you can start to ask a question a little bit more about what's the level of quality in the round for that particular product. A bit more about quality marks. As I said earlier, the presence of a quality mark confirms conformity with the whole of the standard. It also confirms third-party attestation and regular audit. And the individual quality marks are equally valid in terms of conformity to the standard. However, a quality mark, again, does not necessarily confirm that a valid management system is in place, although some quality marks, e.g. the NF mark in France, do in fact require that valid management systems are in place, but they don't always do that. So I guess this is the next level up. If you've got a CE mark product and then you've got a quality mark on that, at least you know that that product is in conformity with the standard, but that's no guarantee that the actual manufacturing processes are consistent. So again, it's about how we wrap layers of approval onto products and what those layers of approval mean. You've then got management systems. So again, as a manufacturing company, from a Saint-Gobain PAM perspective, we also wrap these around the product. We don't just have a CE mark and a quality mark. We also have a management system that we have to manage and control. And this talks about the quality in the environment. So as a base level, we've got ISO 9001, or ISO 9001 is required. And basically this is so you have a quality process, a published quality manual that defines the quality policy, the commitment of the company, defines the precise role of each member of the organisation, and ensures that designers, manufacturers, salespeople all must work to a designed process, and that the system is subject to third-party audit and certification. So basically 9001 is your manufacturing control and your business management systems. So if you've got a CE mark, a product approval mark, and then an ISO mark, you've generally ticked most of the boxes that you need to ensure that you've got the highest level of quality on a product that you're specifying or using. In addition to that, you've then got environmental standards, which are becoming more and more relevant and prevalent now. So again, people aren't necessarily always just satisfied with ISO 9001. They want to understand a bit more about 14001, which covers respect for people in the environment, which is the basis for this management system. It's ensured that production sites are all tested and adapted to cause the least harm to people and to improve the working conditions of staff. It incorporates recycling, reduction, waste sorting, energy control, transportation, raw material and finished products, and demonstrates that all of these processes are subject to essential controls for the smooth running of the business. So it's managing the raw material and the waste channels there to ensure that consumption is kept to a minimum, and where possible, you've got recycling and reprocessing in place rather than consumption of new materials. And again, environmental standards, ISO 14001, are subject to third-party audit and certification. So again, from your guys' perspective in the room, if you're defining a product or specification for a product, as I mentioned earlier, if it's a construction products directive product, a harmonized product, you can ask for a CE marking as your base point. You can then ask for a reference to a European standard, then you can ask for a quality mark, then you can ask for a management system. If you get the management system on top of all that other thing, you've covered all those bases for stringent quality control and product management control of a particular product. So to put that into a bit more, into a bit of context, the schematic here, I guess, demonstrates what I've just been talking about. So at the lower level, you've got the CE mark, which is good in itself, because that means you've got a declaration of performance to a particular standard. And in theory, a manufacturer's claim of conformance to a standard offers a higher level of performance than a CE, but there's no guarantee that unless that is accompanied by a third-party approval or third-party certificate of conformance, there's no guarantee that it meets that. A manufacturer demonstrating compliance with a standard via a national recognized quality mark or an environmental standard gives that next level and a higher level of assurance on a particular product. And then when you've got that, if you can back that up with quality and environmental control standards, this gives the certification offers the highest level of security for a product. And if you note as well, in terms of management systems, these approval bodies are themselves approved and validated by third parties. So you're building a layer of if you like, of quality assurance and security around a product, because, for example, in the UK for management systems, BSI are audited by UCAS, who are validated to measure and manage whether BSI or Bureau Veritas or Lloyd's or whoever it might be are accredited to carry out these types of audits. So the auditor gets audited themselves. So there's a whole host of approval processes. A whole host of approval processes that are wrapped up into quality standards to make sure that we're meeting that highest level, or you can ask for that highest level of assurance. So as I mentioned there, that's that UCAS mark. So to summarize, in terms of European standards, it's a bit of a dry topic, standards is, so forgive me if it's been a bit boring, but it gives a good background into what standards are and how they work. But to summarize, European standards are created by consensus between the member bodies representing 31 member states. Brexit has currently not affected the UK participation in that, and SEN recognised the need and the strength of the UK membership on standards committees. European standards, ENs, are created by nominated experts representing manufacturers and users via a robust and transparent system. So there's an iterative process there, and there's opportunities for people to comment and either oppose or support recommendations. It's a precise definition of what a product is. There are different certification points that have different values, and a CE mark is not a quality mark. It's just a manufacturer's, if you like, a manufacturer's product approval. So that's it for this particular presentation. As I mentioned earlier, it's perhaps a little bit dry at times, but that gives us a flavour of standards and how they're made, how they work, and how they should be applied to products.